Start. Ready? Armela कर आलनी, ये नहीं, सुबह ये था नहीं. Now the students, I welcome you in this session. Last class I have told you some preparation of potassium permanganate and some of the reactions. Now I will give the oxidizing action of potassium permanganate. I will show you. Potassium permanganate in the last class I have told you exhibit both acidic and alkali or neutral medium. Now in the acidic condition it changed to ferrous to ferric. Let us see in ionic reaction we write like this. Ferrous to ferric, number 1, MnO4 minus plus 5E plus 8H plus, it form Mn plus plus 4H2O, ferrous to ferric, ferrous change to ferric, P plus plus plus. Now since it involves 5 electrons, here is plus 3, here only 1 electron minus E. Because 3 plus is there, if we add 1 electron, it will balance to plus 2 plus. So multiply this 5 and you add this, yourself you add this. See the reaction of potassium permanganate with ferrous. So when potassium permanganate treated with ferrous sulfate, we get ferric sulfate. Second, it oxidizes oxalate to carbon dioxide, acidic medium, MnO4 minus plus 5E plus 8H plus, it form এই ইকুয়েশন সবল সমান অ্যাসিডিক রা আয়নিক রা সবল সমান plus 4H2O. Now C2O4 minus C2O4 2 minus, it form 2CO2 minus 2E. তুমি নিজে পেলে মিশাই দেব যা আসিব 5. Here is 2 to balance the electrons. Here is 5, here 2. If we multiply 5, 10E, here 2, 10E. It cancel it out. Again, third, it oxidizes MnO4 minus plus 5E plus 8H plus Mn plus 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 4H2O. H2S, we may write this ionically, H2S, we may write this H2S, it form S2 minus, here is S2 minus, here is sulfur plus 2H plus. Since sulfur oxidation is 0, here is minus 2, we have take minus 2E. Hence, we multiply here 5, here is 2. Simple redox reaction like this. Here, manganate potassium permanganate acts as oxidizing agent. Similarly, SO3 to I minus to iodine. I minus to iodine. We may write MnO4 minus, same equation first, 8H plus plus 5E Mn plus 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 4H2O. Last class कही बुझाई देली कहीं 5 वाला कही देली Mn plus 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 4H2O. I minus 2I minus I2, it will minus 2E. minus 2 because 2 minus dita minus अछि dita electron minus the bahar karna ba it will 0 state, so it will be 2i minus 2e i2 at this. So this I2 iodine eta gala, this one I2 iodine. So here multiply 5, here multiply 2, 10 cancel and we add this. Similarly SO3 2 minus to SO4 2 minus, same method, MnO4 minus plus 8H plus 5E Mn plus 4H2O. SO3 2 minus it form plus H2O, it form SO4 2 minus. You see sulfur the oxidation number is here x minus 6 is equal to minus 2. X will be plus 6 minus 2 is equal to plus 4. Here is plus 4. Here sulfur is x minus 8 is equal to minus 2. X will be plus 8 minus 2 is equal to plus 6. So plus 4 to plus 6 gala sulfur. Hence it will minus 2e. We multiply 5, multiply 2 and add the all the equations. Similarly NO2 to NO3 minus, SO2 to SO4 minus, NO2 we may write like similar manner. MnO4 minus plus 8H plus 5E it form Mn plus 4H2O. NO2 minus similarly plus H2O it form NO3 minus plus 2H plus. Here is nitrogen oxidation of plus 5. Here is, look at here, x minus 4 is equal to minus 1. X will be plus 3 state. Plus 3 change to x minus 6 is equal to minus 1. X will be plus 5. Change from plus 3 to plus 5. You have to minus, it will be 2e. Multiply here 5, 2. Add this. Similarly, sulfur dioxide to sulfate. Sulfur dioxide to sulfate. MnO4 minus plus 5e plus 8H plus form Mn plus 4H2O. It is balanced, ionically balanced, electronically balanced. SO2 plus H2O, 2H2O, it form SO4 2 minus plus 4H plus. So here we have minus 2e. Add this 5, add this 2 and add the equation. So this all about the oxidizing action of potassium permanganate in acidic medium. Now we will go to the alkali or neutral medium. Let us discuss the oxidizing action of potassium permanganate. The oxidizing action of MnO4 KMnO4 in neutral or feebly alkali medium, alkali medium. In the feebly alkali or in neutral medium, at that case KMnO4 change to manganese dioxide. Look here, KMnO4 change to manganese dioxide. At that case manganese sulfate Mn plus plus. Here manganese oxidation number will be x minus 4 is equal to 0. Actually plus 4 state. Here is manganese plus 7 state. Plus 7 state change to plus 4. Hence we have to add 3e. Then MnO4 minus, you may write this MnO4 minus plus 3e. It form MnO2 plus H2O. It will be, whether it balanced or not, we will see 2H2O, right? It will be 4OH minus. MnO4 minus plus 3E plus 2H2O MnO2 4OH minus. In this case, it oxidizes manganese plus 2 state. Number 1, it oxidizes manganese plus 2 state to MnO2. B2, it oxidizes iodide I minus to iodate. सेठी iodine होतला एटी बारे neutral medium वाले iodate. So Mn plus 2 to MnO2. Now first equation is MnO4 minus plus 3E plus 2H2O. In acidic medium it is 5E, in alkyl medium or neutral medium it will be 3E. Hence it will be Mn plus 2 will be MnO2 plus H2O, Mn plus 2 plus H2O, 2H2O, MnO2 plus 4H plus. तापरे तमे ताको मिसे दबो. Now electron, you look at it. Electron plus 2, here is plus 4. Plus 2 minus 4 plus 2, it is plus minus 2E. Because here is plus 2 state, here is x minus 4 is equal to 0, x is plus 4 state. Since plus 2 change to plus 4, we have to loss of electron, oxidation. How many electrons? 2 ରୁ 4 गले आम 2 इलेक्ट्रॉन दे बाहर करनबा ताले plus 4 हेजबो. ताले hence it will be plus 4. Plus 4 is. तापर ताको नेकी मिसे दबो जासिबो result that is the Mn plus 2 to MnO2. It's changed to I minus 2 iodate. I minus 2 iodate. Similarly, first write down MnO4 minus plus 3E plus 2H2O, it form MnO2 plus 4OH minus. I minus plus H2O, 3H2O, it form IO3 minus plus 6H plus. And the केतरा इलेक्ट्रॉन होचे -1 अछि. -1 to गला इट वर्तमान x minus 6 minus 1 x change to plus 5. Iodine remains oxidation number plus 5 because x minus 6 is equal to -1. X will be plus 5. Here is I is -1. -1 to plus 5 जदि गला ताले we have to add how many electrons? -6e. So multiply here 2. Now multiply here 2 in order to balance the electrons. 6 is cancelled at this equation. So this is the oxidizing action of potassium permanganate both in acidic medium and alkyl medium. Now let us discuss the structure of MnO4 minus. Let us discuss the structure of MnO4 minus. Look at there. MnO4 minus. It is maybe written as it is D3S hybridization, D3S hybridization. Manganese atomic number is 25, 1s2, 2s2, 2p6, 3s2, 3p, 4s2 to the plus 3s2, 3p6, 4s2, 3d. Take up 25, 2 plus 2 4, 10, 12, 18, 20, 3d5. So first we write 3d5. 1, 2, 3, 4, 3d5. 1, 2, 3, 4, 5, 4s2. Since it contains MnO4 minus 3O and 1O minus, each oxygen requires 2 orbital because 1s2, 2s2, 2p4. 2p रे देखो दुईटा 2p4 केमिति रहउची 1 2 3 4 2 आर पार्शियल फील्ड दुईटा दरकार पड़बो ऑर्बिटल ये 3O तीनटा 6 गोटे दरकार पड़बो O माइनस 7 दरकार अनपेयर. सो 1 इलेक्ट्रॉन फ्रॉम 3s 3p गोटे इलेक्ट्रॉन जॉब करे दियो 1 1 1 1 1 3p 3s 3d, this is 3d, this is 3d and this is your 4s. 3d it is 4s. 4s रे गोटे then go to 4p. 3d 4s 4p. 4p गोटे नहीं गले 3d it is 4s it is 4p. তাহলে কেতটা হলো 1 2 3 4 5 6 7 each oxygen atom, then D3S, good hybridization, D3S. One oxygen goes to, it is unhybridized, these are unhybridized, and this is unhybridized. So one oxygen goes to this forming unhybridized pi bond orbital, another orbital goes to hybrid paco sigma bond. Same as another oxygen, it goes to here pi bond, it goes to sigma bond. Another oxygen forms to sigma bond, another pi bond. ଆଉ ଗୋଟେ ରହିଲା ଯୋଉଟା ଗୋଟେ D3S, ଚାରିଟା ଅଛି, ତିନିଟା ଗଲା ବର୍ତ୍ତମାନ ଅକ୍ସିଜେନ୍, 3 oxygen, one O minus goes to here, O minus, here ଯାଏ O minus goes to here, O minus, hybrid paco. But this O goes to pi bond. Hence it is the structure of D3S hybridization, and the structure is like this: S O O O O minus. It is tetrahedral structure. Sorry, this is your MnO4 minus Mn, sorry, Mn, তারপরে আসবে কোন তোমার O O O O minus. Manganese. So this is the sigma bond, pi bond, sigma bond, pi bond, sigma bond, pi bond, and this is only sigma bond, O minus, O minus. It is only your sigma bond. It D3S hybridization, the structure is tetrahedral, structure is tetrahedral. Hence this is all about your potassium permanate, MnO4 minus. MnO, MnO, O, O minus. Now I have discussed then F block element. I told you D block element. Now I have discussed in F block element क्या कुआ जाए कौन? F block elements. F block elements. If the last electron goes to F orbital, if the last electron goes to F orbital, যদি F orbital को जीव, then last electron, then this is called, then these are called F block elements. These are called F block elements. These are called F block elements. Now I will give some F block elements. There are two series. One is 4F series, another is 5F series. Two types. The F block elements classified two categories. So this is called 4F series is called lanthanide series. It's called lanthanide series. And 5F series is called actinide series. Actinide series. There are two series. One is lanthanide series, another is actinide series. Now I am writing what are the lanthanide series elements. Lanthanoids that comes after lanthanum. The elements containing cerium, it is cerium, atomic number is 58, Pr 59, Nd 60, Pm 61, Sm 62, EU 63, GD 64, TB 65 dy 66 helium HO 67 erbium ER 68 TM 69 YB 70 lutetium Lu that is 71. Then the elements coming atomic number 51 to 71 are called lanthanides because they come after the element lanthanum. Lanthanum is 57 which is d block element. Lanthanum pare amar electron gale F को आसीबो जेहेतु F को आसी these are all are F block elements. These are all F block elements and these are hence it is known as lanthanides because these elements come after lanthanum. जेहेतु lanthanum परे आसी सेति आमे त कहले lanthanides. So it's general electron configuration of lanthanides. General electronic configuration of lanthanides is your xenon. What is the general electron configuration of lanthanides? You write down xenon 4f 1 to 14 गोटे रु आरंभ 4f 1 to 14 5d 0 to 1 6s2 आगे अभ्यास प्रिंसिपल अनुसार 6 आगे फिलअप है. Then comes to 4f xenon 4f 1 to 14 5d 0 to 1 6s2. These are the general electron configuration of lanthanides. Now individual electron configuration I will take 58 cerium. I am writing cerium electron configuration of lanthanides writing cerium. Let us discuss cerium रे केमिति करबा. cerium आगे lanthanum लेख lanthanum it is 57. Its electron configuration is XE 4f0 is not a d block because 4f0 5d1 6s2 lanthanum. Then cerium which is a block element. Cerium narambala 58 to 14 elements. Cerium 58. Next electron goes to F paku. Xenon it will be xenon 4f1 5d1 6s2. Then PR 59 खाली F नंबर बढ़े दबा बढ़े देखिए 5d टू कम पढ़े आसो ताल xenon 4f3 6s2. ND 60 it will come xenon 4f4 6s2. Then PM 61 xenon 4f5 6s2. SM here will be सब समान 4f6 6s2. EU it give 4f7 6s2. Gallium GD 4f7 5d1 5d1 6s2. GD then TB I am writing out TB is 4f7 4f9 4 xenon 4f9 6s2 6s2. Then dy will be general 4f10 6s2. Like this last stage lutetium is 4f14 5d1 6s2. So I find that cerium, the common, let us discuss the oxygen state. The common oxygen state of lanthanides are +3. The common oxygen state, what is the common oxygen state of lanthanides? You have told that +3. Out of this +3, this +3 যদি আমি বিদা করে দেবা তাহলে it is stable compression, it is genuine compression comes, it is +3. The other oxidations are there, it exhibit +3 and +4. The cerium exhibit +3 and +4. This also exhibit +3 +4. Main point is EU is the half fill it exhibit +2 and +3. It exhibit fulfilled +3. +3 because its compression is 4f7. So these are some oxidation state. Last one, the 4f14 it will be stable state is +3. So the common oxidation states are +3. Out of this, some exhibit +2 and some exhibit +4 also. This is the common oxidation state of lanthanides. Now most important point is what is lanthanide contraction? Your very important point, what is lanthanide contraction? The lanthanide contraction, जोटा कि परीक्षार बहुत सब पड़े, what do you mean lanthanide contraction? Lanthanide contraction क्या कहबो? What is lanthanide contraction? हम तो क्या कहबो ताको देखियो पड़िबो. What is lanthanide contraction? Contraction means decrease of size. So lanthanide contraction definition is, this is the lanthanide contraction होची may be defined as the steady decrease, of size of lanthanide ions with increase of atomic number, with increase of atomic number. जते atomic number बढ़िले तामाने size कमी जीवो. तान cerium to lutetium the size decreases. The decrease of size is called lanthanide contraction. So, graph जदि करिबा atomic number जदि बढ़िबा lanthanide रो, the size gradually decreases. With increase of atomic number, the size decreases. It atomic number, the size decreases with increase of atomic number of lanthanides are called lanthanide contraction. Then we have to call cause of lanthanide contraction. Kahi ko hochi? The reason called. Then we can explain the cause of lanthanide contraction. Number one, due to inner 4f electrons. Due to inner 4f electrons. Okay, देखिए वो 4f1, 4f2, 4f3 the electron जाउची. That is due to first imperfect shielding of 4f electrons. The f orbitals are diffused. The f orbitals, if are concerned again, f orbitals are diffused. Since f orbitals are diffused, then the nuclear charge is बढ़ी बढ़ी जाऊँगी किंतु आमर size gradually कमुची because the force of attraction increases due to increase of, that is due to increase of effective nuclear charge, effective nuclear charge with increase of atomic number, with increase of atom जिते atom बढ़ी कहीं effective nuclear charge हम बोलला बेलू the force of attraction, it plus the minus the electron, the force of attraction increases and the size decreases. This is the one of the cause of the lanthanides. Then consequence of lanthanide, tinta point. What is lanthanide contraction? Then we go to the cause of lanthanide contraction. Then we have to discuss consequence by after effect of lanthanide contraction. Consequences of lanthanide contents or after effects. After effects of lanthanide contraction. After effects of lanthanide contraction. Lanthanide contraction. Number one, कौन टाइप होची ionic radius decreases. First number one, ionic radius decreases. Radius decreases with increase of atomic number. With increase of atomic number जते atomic बढ़ुची lanthanide रो बाम डाउन पट गला को साइज डिक्रीज करछि दैट इज ड्यू टू 4f इलेक्ट्रॉन सिलिंग पे हमरो इफेक्ट पड़छि सिलिंग पे इफेक्ट पड़े द्वारा फोर्स ऑफ अट्रैक्शन बिटवीन द न्यूक्लियर चार्ज एंड इलेक्ट्रॉन इंक्रीजेस एंड द साइज डिक्रीजेस बिट 2 इज decreasing of basic strength from lanthanum HO3 lanthanum ru to lutetium OH3 plus the state, that is lutetium hydroxide LuOH3 is least basic. कहीं बुझेबा it is more basic. OH3 LaOH3 it is more basic. ताल basicity gradually decreases and the size decreases according to Fajans rule. जते size decrease हेले when the size is decreases हम the size decrease कले Fajan rule कहला covalent character increases. ताल covalent जदि बढ़ला the more is the covalent less is the basic. So it is more covalent, hence due to more covalent the basic decreases into least basic and lanthanum hydroxide is more basic. That can be the consequence of lanthanide contraction. Number third point, 0 करनियम hafnium size, neomethanum Ta and molybdenum tungsten in D block elements कहते D block element ये जो size difference बहुत कम बराबर समान नहीं पारे. So this size comes because due to lanthanide contraction, due to size बेसी कमी जाउची जे size बेसी कमी होला को ताले पाखापे को ऊपर तळ समान हो जाउची. Due to the size it practically remains same due to lanthanide contraction. Then some of the reaction of lanthanides, then we'll discuss some of the reactions of lanthanides. गोटे घर काटि कहि दउ बुझे दउची. Suppose this is your lanthanum plus 3 Ln plus 3 lanthanide with oxygen O2 it give Ln2 O3 lanthanum plus 3 state Ln2 oxygen it give lanthanum means Ln plus 3 is what Ln total lanthanides plus 3 state either may be begin with sodium may pare potassium may pare jekon din chai pare oxygen misle it gives Ln2O3 General name is these 14 elements. I am the general name dekhle Ln plus 3. All the lanthanide elements are named as Ln. I am the Ln kale. With acids liberate hydrogen gas. Lanthanide liberate hydrogen. With water H2O, it give LnOH whole 3. With carbon, it give LnC2. With nitrogen, it give LnN. With sulfur, give Ln2H3. In the D block elements, D block color the color of the D block elements are due to D tension, but here the color of the tension element of the inner tension elements with lanthanides are due to the color of this color. We can explain the color by due to F tension. It is F tension. So D tension because it is partial field electron, F tension. If question asked where cerium plus 4 is color or not, cerium plus 4 is color or colorless. Cerium is color formula is xenon 5D 4F1 5D1 6S2. Cerium plus 4 will be this cerium plus 4 will be 4 electrons can be removed. It attains the configuration of xenon. There is no unpaired electrons in F subshell. Therefore, it is called. There is no possibility of AF tension. So the AF tension possible holding. So it is colorless, and cerium plus 4 is colorless. Why it is colorless? You can explain by means of electronic configuration. Why this is colorless? Similarly, you can explain GD3 plus is colorless. Lutetium Lu plus 3 is also called. These are colorless. You can explain by the similar method. Because it is colorless. And the magnetic nature, D block the magnetic nature, the same way, if it contains unpaired electrons, then it's paramagnetic. If it contains paired electron, then diamagnetic. No unpaired, diamagnetic. So if it is unpaired, spin that dita spin orbital ta kaam kare. इसमें हमरो tally पूरा करे नहीं. Dira contribution, spin contribution, orbital contribution. Only spin contribution depend on the number of unpaired electrons. If the unpaired electrons is the formula is n plus 2 जोटा मु डेवलप कही रूट ओवर. From this we can calculate only the spin value, not we cannot calculate orbital. Since orbital contribution there, the total value calculated from this spin value cannot tally with this. Now these are about lanthanides. Now look at the actinides. The elements coming after actinum 89. Actinum ପରେ जो element आसिला thorium. The elements coming after actinum are called actinides. After lanthanum are called lanthanides. The elements are coming 890 because 92 the elements begun 92. The value is 92 LR 103 atom number. So these 14 elements present here, thorium 92, LR 103, these are called actinides. The lanthanides and these are called actinides. This lanthanum पर हम कहते lanthanum, cerium lutetium जो कहते cerium lutetium, these are this is 57, 58 to 13, 71 these are called lanthanides and these are called actinides. So actinide general formula is 4F, a general electron configuration of general electronic configuration of actinides. So 4F thila, it will be 5F. It will come 5F, 1 to 14, then 6D, 5, 1 to 14, 6D, 1, 7S2. 0 to 1, 6D, 0 to 1, 7S2. This is the general electron configuration of actinides. So thorium, for example, there electron configuration I am showing, electron configuration thorium. Thorium is 90. For example, thorium aslibo LR, last is LR 103. In the thorium, the configuration is Rn right on 88. (6D1) right, 6D1 7S2. It is the your first actinum 89. First is actinum 89, so it will come Rn 6D1 7S2. It will be 5F1. So n minus 2, n minus 1, it is n configuration thorium. Then Pa, ketna example koi do, some examples. Pa, this is 5F2, 6D1, 7S2 actinides. Uranium 5F2, 5F3, 5N1, 5F2, 5F3, 6D1, 7S2. This one last stage will be lutetium. Last stage 5F14, 6D1, 7S2. So F1 to F14, these 31, the electron goes to F1 to 14, these are called actinides. Similarly, with the lanthanide contraction, the size also here decreases. The size is also decreases. The size decreases. This decrease of size of these elements, of 5F elements, are called actinoid contraction. So that is lanthanide contraction. This is called actinoid contraction. One is lanthanide contraction, another is actinoid contraction. So lanthanide contraction and actinoid contraction, we can explain 5F electrons, but 5F electrons जो जाऊँची, जो contraction of the size gradually decreases from thorium to Lr, lutetium. Hence, the size decreases. Therefore, this decrease is due to actinoid contraction. In the 4F orbitals, I have told that is your lanthanide contraction. The common oxidation state of these actinides are +3. Common oxidation is +3. Well, actinum only shows +3 because आगु देखि परिबन. This actinum Rn जोड़ होची. किंतु वर्तमान this element thorium can exhibit +3 and +4. Why +3 and +4? Because if we remove 2, 1, 1, it will attain the configuration of radon, which is the stable electronic configuration. Which is stable due to stable electronic configuration, it exhibits +4 state. the question arises whether the +4 state of thorium +4 is color or colorless. You see, if we remove these 4 electrons, it will attain the color of, there is no unpaired electrons, there is no FF tension. There is no FF tension, there is no FF tension, hence it is colorless. Though this is about your lanthanides and actinides. What are lanthanides? What are actinides? The elements coming after actinum is called actinides. The elements coming after lanthanum, that is called lanthanides. These are called inert tension elements. D block elements are called are transition element, whereas A block elements are called inert transition elements. Transition and inert transition. Now let us discuss some of the applications. I will discuss some of the applications of lanthanides. Lanthanides and D block elements. Uranium is the actinides which are used for atom bomb. Uranium by nuclear fission, that can be done nuclear fission, the uranium can be used as atom bomb. And some of the applications of D block and D block elements. First I will show some applications of D and applications of D and F block elements. Applications of D and F block elements. First is catalytic properties. They exhibit catalytic properties. Catalytic properties, which are important. Catalytic properties. Industry theory होची catalytic properties रे catalyst भाव काम होई कि हमर कम खर्च रे हम प्रोडक्ट पाई होचंती. Catalyst, for example, Haber's process. For manufacture of ammonia, for manufacture of ammonia, we take N2 plus 3H2, we get 2NH3 plus 22.4 calorie. So here the catalyst used, your D block element, that is your iron. Iron acts as catalyst. Iron dele ame quicker paiba, the potential more. So final divided iron is used as catalyst. For example, write one application of D block elements, you will write catalytical property. In the Haber process, we can manufacture ammonia. For manufacturing ammonia, the iron acts as catalyst. Catalyst means nije reaction ne quicker karibo. Proceed the reaction very quick. Kintu nijor kisi change hobani. Itself does not change, but it increases the rate of the chemical reaction. Another example, vanadium pentoxide, V2O5. Vanadium pentoxide is also used catalyst. It is also a catalyst for manufacture of sulfuric acid. So vanadium oxide, pentoxide, V2O5 can be used as a catalyst for manufacture of sulfuric acid. क्यों V2O5 पे लागू बर्तमान देखो V2O5 केमिति करछ. Similarly, another example is there. That is due to why they form catalyst? Because number one, that is due to variable oxidation state. Variable oxidation state. Due to variable oxidation state, it exhibits a very catalyst karipare, and it decreases the activation energy. It decreases activation energy. So the activation energy commijibo, the reaction will be quicker, decrease the activation energy. So these are some of the applications of vanadium. Let us discuss sulfur dioxide. Vanadium pentoxide will discuss vanadium pentoxide. It's a catalyst for manufacture of sulfuric acid. Give me sulfuric acid. The equation is 2SO2 plus O2. It first form B2O5. Last equation this is B2O5. It form SO3. Or SO3 with water, soluble water. SO3 plus H2O. It form sulfuric acid. H2SO4. Sulfur dioxide with oxygen form sulfur dioxide. So, first you may write this equation one way B2O5 plus SO2 sulfur dioxide it form SO3 plus B2O4. The B2O4 is unstable. Due to B2O4 unstable, immediately change to B2O4 plus half O2 it form B2O5. So hence it is remain unchanged, but it decreases by it lowers the activation energy. Therefore, this acts as a catalyst. Question why the transition elements are used as catalyst explain. You can explain by this way. So it also form alloys, formation of alloys. It helps alloys it is formation of alloys used as formation of alloys. Number 3 use atom bomb coily used as atom bomb. So like this. So this is all about your lanthanides and actinides, D block elements and A block elements, potassium permanganate and dichromate we have discussed previously. We have discussed. So thank you all.